So thank you very much, organizers, for having me, and it is much pleasure to be here. So my name is Tomohiro Ishizu. I recently moved back to UCL from University of Vienna. So the studies I will be talking about today are the things I have done in both institutes in London and in Vienna. So today I'm going to talk about the brain mapping studies on aesthetic experiences, especially how the brain works, how the brain responds to the experience of beauty and its subtypes. So firstly, I briefly talk about the findings from brain mapping studies, as well as the criticisms towards such neuroscientific findings. Then I try to make a response to one of the criticisms by introducing an fMRI study in which we studied negatively balanced experience of beauty. And finally, I talked about a slightly different approach to study visual aesthetic experiences by introducing inherited concept and acquired concept. I tell you in detail in minutes. Now, it has nearly 20 years since the first publication of this field. Neuroaesthetics firstly started with trying to identify brain systems particularly engaged in the experience of beauty. As we have seen in the wonderful talks yesterday and this morning as well, some key structures have been identified so far, so which include regions and networks shown here. So activation within those regions correlates to the experience of beauty or other aesthetic experiences. For example, being moved represented in default mode network, as well as sublime and ugliness, for example. So this means that we already have some big picture. It may be still rough, but big picture on the aesthetic experiences. So among these regions, I want to talk more in detail about the area of medial orbitofrontal cortex, ventromedial prefrontal cortex. So this cortical area of the complex of MOFC and BMPFC is known as a dopaminergic dominant system, and as a part of the reward circuit of the brain, and has been found to be active in many fMRI studies, as well as meta-analysis papers in relation to the experience of beauty and other, as well as aesthetic preferences. So it is known that this region is responding to the experience of beauty derived from a range of sources. For example, it is stimulated by beauty in these figurative stimuli, including faces, scenery, and I think that Oshin will be talking about the architecture of beauty as well as artworks and music here. So in which we need some intellectual interfaces and some knowledge to appreciate its beauty. This region is also responding to more abstract stimuli, like beauty in color or beauty in motion, kinetic stimuli, as well as beauty in mathematics and beauty in morality. So they are heavily dependent on knowledge or other factors like cultural backgrounds or context. So these findings may suggest that the area of MOFC BMPFC seems to play one of important role in the experience of beauty. However, there have been apparently some criticisms around the activation of this region in relation to the experience of beauty. So I want to bring up one specific critique here, which relates to pleasure, and it may also relate to the problem and question of the relationship between beauty and pleasure. So firstly, we all know experientially that the experience of beauty is mostly pleasurable experience. We know that. But we also know that the region MRC BMPFC is known as a part of reward circuit of the brain, which robustly responds when we perceive pleasure or anticipate pleasure. So standing on this point, then one might think that if beauty is tied to pleasure, and it's hard to distinguish between beauty and pleasure, the activation within the MOSC BMPFC, which neuroaesthetics has found so far, probably just because of the pleasurable experience, and it is nothing special with the experience of beauty. So this critique has been crystallized in some article, such as Nature column by Philip Barr, or an opinion paper by John Heyman here. So I'm just going to read this. Although it is worth knowing that musical cues are neurologically akin to the responses invoked by sex or drug, an approach that cannot distinguish back from barbiturates is surely limited. And also Heyman says, since as far as pleasure goes, what neuroaesthetics discover also applies to hamburgers and ice cream manufacturers, it tells nothing about Picasso and Cézanne that doesn't apply equally to Haagen-Dazs and McDonald's. So these critics, in other words, if activation pattern from viewing beautiful artworks is the same as those invoked by eating hamburgers, what's the point of the finding? All you can say from such neuroscientific finding is just beauty is pleasurable. Beauty is pleasure, nothing more than that. Then it doesn't give any new insights into existing theory of aesthetics or new knowledge of brain researches. So this is nothing. So, well, beauty is pleasurable. That must be true. And it is also true that it is difficult to distinguish between the two experiences. However, the pleasure we get from viewing beautiful paintings or listening to wonderful piece of music may have different characteristics from the pleasure we get from eating hamburgers or being high with taking a drug, or so on, so on, so forth. Now, I'll show you. The pleasure mentioned in these critiques, such as food, drug, and sex, could be falling into the category of primary reward. And primary reward leads to pleasurable experiences. And as a consequence of having them, they are strongly tied to high positive emotional valence. So eating hamburgers, having sex, all of these primary rewards have to have high emotional valence. And it is usually thought that beauty is also closely linked to pleasure and high valence, high emotional valence as well. And that's, of course, that's true. But it is not always the case. Beauty can be experienced with a negative, low emotional valence too. So recent years, it has gained a lot of attention in empirical aesthetics and cognitive sciences on the relationship between positive aesthetic experience and negatively valenced emotions. For example, enjoyment of sad music, listening to sad music, or watching a sad film, as well as a sublime awe experience are one of the such experience of the mixture of positive and negative affections. And so far, lots of fantastic theoretical and empirical studies papers are published coming out from MPI here as well as University of Vienna. So, but here is another example, which is sort of for beauty. So here is Pieta. Then in early time today, Beatrice also shows the picture of Pieta and saying that you don't need the knowledge or you don't need the expertise to appreciate the emotion depicted in this sculpture, and that's true, and that's really yes. Because first time I saw this sculpture, I actually wept. I cried. I was just a kid. So, kid, I mean, I was an undergrad student. But I didn't have a knowledge for Christianity or religious connotation or the life of Michelangelo. I didn't know nothing about that. But I wept because I felt so beautiful, but at the same time, so sad and so painful. So, I think this is another good example. Sorrowful beauty can be regarded as a combination of positive aesthetic experiences, which is beauty, and negatively valenced emotion, which is sadness. And then there is a question. So if the MOFC, BMPFC respond to such experience of sad beauty, it can be said, at least it can be said, that this region does not simply react to the high valence, high emotional valence accompanied with pleasurable experience, but it reacts to something different. So to study this, firstly, we wanted to elucidate sorrowful beauty by separating to joyful counterpart in a behavioral study. So in this behavioral study, we had 800 pictures, something like this, and asked our participants to rate according to two qualitatively different kind of scaling. One is emotional valence scale, ranging from very sad to very joyful, as well as the aesthetic beauty ratings, ranging from very ugly to very beautiful. So this is what we got from the behavioral testing. The x-axis denotes the beauty rating, and y-axis denotes the emotional rating, both ranging from 1 to 5. And let's look at these clusters on the far right. And this cluster, in this cluster, participants rated 5 for beauty rating. So this was experienced as very joyful, and also 5 for emotional rating as well, which means very joyful. So in this cluster, in this stimuli, participants experience joyful as well as beautiful. But in this cluster on the bottom, so this can be regarded as sad beauty because it has got a 5 for beauty rating, which is very beautiful, but 1 for emotional rating, which is very sad. So this cluster can be regarded as a sad beauty. So this simple behavioral result suggests that sad beauty, which is negatively emotionally balanced beauty, can be separated to the positive counterpart. Then we put the same paradigm in the MRI scanner and recorded brain activity on the participant while they are doing exactly the same task. So this is what we got. As we see in the top row, there is significant response, statistically significant response within the MORC, BMPFC area in both joy plus beauty condition and sad plus beauty condition as well. Then conjunction analysis showed that there is a significant activation within this region. So that means both beauty subtypes, sorrowful beauty and joyful beauty, can stimulate the MRC and BMPFC. So this region can respond to not only positively balanced beauty, but also negatively balanced one as well. which primary reward like food, drug, and sex never have. Okay, so I think I'm going to skip this one. So, to further understand the difference and the characteristics of solo for beauty, we applied the functional connectivity analysis. Then this functional connectivity analysis enables us to study which regions show activation patterns that co-vary with activity of a seed region. So in this case, we set the medial orbital frontal cortex, BMPFC, as seed region. Then we found a greater connectivity for solo for beauty between MOSC BMPFC and supplementary motor area and mid-cingulate cortex, and as well as those lateral prefrontal cortex, which we can't see in this field. And so this marked in blue has a greater functional connectivity to MOSC. Whereas between MOSC BMPFC and rostral part of medial prefrontal cortex shows the greater functional connectivity for joyful beauty condition, which marked in yellow here. So there is a distinct pattern of brain activation between two different beauty experiences here. So supplementary motor area and MCC and DLPSC are of particular interest because those regions are thought to dedicate to empathy for others' pain and distress, as well as the interpreting others' intention, especially under sad or painful situation. So these results suggest that when we appreciate beauty, we engage not only the region relating to aesthetic experiences, but also regions which are dedicating to social cognition. And specifically, when it comes to solo for beauty, there might be a moderation to the orbitofrontal cortex region from the region which are important to understand as pain and sadness. So this is a summary for the first part. Beauty can be negatively valenced. And pleasure derived from beauty may be something different from pleasure derived from having primary reward. At least it is different from reward accompanied with positive valence, such as having a hamburger or drug. Finally, MOSC BMPFC, which known to respond to positive reward with high valence, also responds to low valenced in beauty experience. So, I think these findings may be able to some response to the critiques around the MRC and BMPFC in neuroaesthetics findings. So for the second part of this talk, I think it's 10 minutes or so, I want to talk about a slightly different but related topic as I discussed in the Sad Beauty, that is the works of Francis Bacon. Francis Bacon's work give aesthetic impact or aesthetic appeal to the viewers, but also the emotion we get from viewing his painting may be categorized as a negatively valenced affection. So Bacon's works may be another good example of the mixture of aesthetic appeal and negatively valenced affects. So I want to talk about a hypothetical work on how the brain might work with the aesthetic impact of Francis Bacon paintings. So Francis Bacon painting actually give us an important insight into human cognition and its brain functions. That is, we may have two different kinds of concept or template to perceive visual outside the visual world or visual object. One is what I call inherited concept, and another is acquired concept. I tell you in detail in a minute. But now, let's have a look at some of his painting here. So in this painting, we can see violently distorted face and body sitting on a chair. And in this painting, it is almost unrecognizable, but severely mutilated human figure on the table. And in this picture as well, you can see the severely mutilated human face here. So one of the distinguished characteristics of Francis Bacon's work must be this violent distortion applied to face and body of models depicted in the painting. And such distortion may give a viewer a strong visual impact, which he himself called as a visual shock. So Bacon himself calls this distortion as a visual shock. Then what is a visual shock then? Now let's have a look at this video.
I want to give you a shock. Now, shock, you could say, is a form of expression. But what expression it is, I don't know. It's a visual shock. It's not a shock about, it's not a shock that you could get from the story. It's just a visual shock.
So this is Francis Bacon talking about his visual shock from BBC archive. So visual shock is, he said, a form of expression. But he didn't clearly specify what the visual shock is. So let's leave it for a while and get back to his painting now, because there is another common feature in these paintings, apart from the distortion of human figures. So there is one characteristic throughout this painting. Do you find that? Now I tell you. That is a tendency in which objects and human-made artifacts like chair, table, or sofa are left intact without applying the distortion. So let's see the chair and table and sofa and chairs looks quite normal. So Bacon violently distorted faces and bodies, which are of course important for human beings, whereas artifacts escape from such distortion and depicted as they are normal, as they are intact. And this tendency can be found, of course it is not 100%, but it can be found in most of his painting, as long as there is a human figure and object. So as we all know, that the faces and bodies are special visual category in human cognition and perception. So there are face selective and body selective regions in the brain. They are including FFA and EVA and other regions as well. Then if you get the damage onto FFA, we can't recognize familiar faces anymore. So these are findings from neuroimaging result. But in addition to those neuroimaging findings, infant studies and baby studies show the evidence that humans are born with and equipped with a capacity to recognize faces and face-like configurations. And it is presented at birth or very soon after birth. So these behavioral infant neuroimaging evidences strongly suggest that humans are born with or almost born with some kind of inherited template or inherited concepts which we use them to perceive and recognize faces or face-like configurations. However, on the contrary, object and human-made artifacts like chairs seem not to have such specialized brain areas and seem not to have such inherited template which faces and bodies have. However, they can be learned and acquired as knowledge. So you can learn new objects and acquire the concept of them and get accustomed to them. And also you can relearn it and update the concept of the object. So once you learn the concept of chair, if you encounter these chairs with strange shape or legs, you can update your concept of chair to recognize them quickly. Therefore, concept and template of man-made artifact are subject to be acquired and to be modifiable. So from this point, we want to distinguish the two categories and regarded faces and bodies as inherited biological concept or template, whereas man-made artifact and object as acquired and artifactual concept. So returning to Francis Bacon painting, what he did in his painting was to be interpreted as to deform the inherited template of faces and bodies and left acquired concept, artifactual concept of chair intact as they appear normal. Then next, it gives rise to another question, why he did this? Why he did it in this way? On what reason he made it in that way? The reason is, of course, unknown to us, but I think from neuroscientific point of view, this may be because of the fact that the distortion of faces and bodies influences the neural response much more than the distortion of object and man-made artifacts. So the clue of this hypothesis can be found in an fMRI study done in UCL lab. So in this study, they examined brain responses when presented deformed faces and deformed man-made objects, such as airplane and chairs, and compare them to those of intact condition of these categories. And participants passively viewed those 4 different types of stimulus set while being scanned by fMRI scanner. And this is what they found. So they found that DLPFC is selectively active in all deformed conditions. So it doesn't matter whether this deformed stimuli is from face or airplane or chair, regardless of the stimulus types, deformed condition activate DLPFC. So DLPFC is known to strongly respond to and send error signal when there is something unpredictable, something wrong, or departure from what is considered to be normal. So for example, when we're looking at this abnormal color banana, blue banana, our DLPFC must be switched on. But the important finding of this study is beyond this. After repetitive exposure to these pictures of deformed faces and human-made artifacts, as well as intact condition, for 1 month, so their participants had to view these strange, funny stimuli every day for 1 month. Then, after the repetitive exposure to those stimuli, and after 1 month, they found that the activity of the DLPFC actually decreased with deformed artifact condition. It may be due to an adaptation effect from the repetitive exposure, but still remained active with deformed face condition here. So these results suggest we do not adapt easily to the violation of the inherited concept of faces or bodies, whereas we can adapt to the violation of acquired concept of man-made artifacts or objects. So I think it is, of course, it is just one hypothesis, it is just one study. It may be wrong, but it's just a hypothesis. I think that Francis Bacon might use this nature of human perception and its brain function unknowingly to optimize his works so that they can sustainably and consistently give visual shock to the viewers. So I think I'm running out of my time, so just want to conclude here. I have talked about how the brain responds to seemingly contradicting mixture of emotions such as sorrow for beauty by responding to a critique to MOFC and BMPFC activation in relation to experience of beauty. And by being inspired by works of Francis Bacon's paintings, which may also a mixture of aesthetic appeal and negatively balanced emotion. I talked about the two different templates of visual perception we have. So in general mind, we think of beauty as positive, happy thing, but as we have seen here, beauty can be sorrowful and sad, or sometimes gruesome. The brain may recruit the same system, including MOFC, BMPFC, and other reward-related regions, but it also engages the network for empathy and understanding others, and that may enable us to experience seemingly contradicting experiences of mixture of negatively and positively balanced affections. So these studies are supported by Wellcome Trust and Japan Society for the Promotion of Science, and thanks to colleagues in UCL as well as colleagues in Vienna, and thank you very much for your listening.